All right, so today we're going to be talking about angles in and on circles. So I decided to split up the circles unit into two different units. So we're going to be talking about these for the next 2 weeks or so, and then we'll have a test. So basically, we're just going to talk about different angles with circles. So these first two, I believe, are really, really cool, and you're going to see them a lot. A center angle is an angle that forms when two radii meet at the center of a circle. So this is a radius, and they meet at the center, okay? And the cool thing about a central angle is, let's say if this is like 70 degrees, which this is not drawn to scale, then this arc length would also be 70 degrees, which I think is pretty cool. So for example, like same thing, if you knew the arc length, let's say this arc length is 90 degrees, then this angle would also be 90 degrees, which makes sense because the angle measurement around an entire circle, we all know, is 360 degrees. So like if you take a quarter of this whole pie, right, that's 1/4 of 360 is 90. So it makes sense that these would also be the same. Okay, so let's go down to an inscribed angle. Okay, an inscribed angle, okay, is basically where you have two chords. A chord is just a line that goes through a circle, where two chords meet at the have a common endpoint on the circle. So basically, two chords meet at or on this circle. So what's cool about inscribed angles, which isn't listed on for either one of these descriptions, but basically if I know this, let's say it's 20 degrees, the arc length is double what this angle is. So if this is 20, this would be 40, and then vice versa. So if I knew this was, oh gosh, sorry about that. Oh wait, I don't know what I'm doing. Let me start over. If I had a circle and I had an angle, kind of looks like this. Let's say this arc length was 160 degrees. We know that this angle measurement is going to be 80 degrees, okay? Because we can take half of this arc length to find that angle for an inscribed angle. So those are two things that I want you guys to be able to know. And then we're going to go to two more cases. So let's say we have a tangent and a chord. So this tangent is just a line that runs right next to, it touches the circle, it just runs right next to it though. Okay, it doesn't go through the circle, it just goes next to it. And then a chord, like we said, is just a line going through a circle. So if these two intersect at this angle, the arc length, okay, so it says an angle formed by a chord and a tangent that intersect on a circle is half the measurement of the intercepted arc. So let's say this arc, this is our intercepted arc right here. Let's say this arc is 80 degrees. That would mean this is 40 degrees. So we can just take half of this arc to find the measurement of this angle. Okay, so I kind of already did an example, but let's say this one is like 35 degrees. The measurement of this arc would be double that, which is 70. Okay, so that'd be an example. All right, so let's look chord and chord. So let's just say we have two chords going through a circle. Chord here and a chord here. Okay, now this is pretty cool because we've learned this. These are called vertical angles and that those are the same, okay? And then you can see here, we also have another pair of vertical angles here and here. And that would mean that these two angles are congruent and these two are congruent. So let's just keep that in mind when we're looking at these. But the measure of the angle formed by two chords that intersect inside the circle is 1/2 the sum of the chord's intercepted arcs. So intercepted arcs are basically just like where these two chords cross over, the two arcs that's inside of them. they're intercepted. Okay, so they're captured by these two. Okay, so if I added these two together and divided it by 2, okay, it would give me the measurement of one of these angles, so either this angle or this angle. So looking at this example, over here, let's say this is 20, or let's say 40 degrees. And then let's say this is 80, okay? What I would do, and I'm trying to find this angle right here, what I could do is I could do 80 plus 40 and divide that by 2. This would be 120 divided by 2, or 60. So I know this angle is 60 degrees. Okay, pretty easy. So then if I know this is 60, this is also 60. This angle on the other side is 60. Now, can I find the other two angles? Hopefully you'd all say yes, because Ms. Garner's hopefully drilled this into your mind that if we have a line and we know one of these angles, okay, and we know a line is how many degrees all the time. It's 180 degrees. So I can do 180 minus 60, and I can get this, which is 120. Okay? Yeah. And so if this is 120, this side's also going to be 120. Okay, so that's just helpful for you to know, to kind of keep that in mind. But let's do some example problems. All right, so the first example problem, I'm going to kind of zoom in a little bit so you can see. Okay, there we go. Hopefully that's good. All right, so this first one, we're going to always look and see what it's asking for. So it's asking for the measurement of this arc. Okay, so I can kind of assume, right, this 65 is talking about that angle right there. Okay, so if I know this is 65, I'm going to look back at my definitions, and I'm going to look, I'm given a tangent and a chord. So let's go back up here. It says tangent and chord. And so what this said was that the angle that is intersected by the tangent and the chord that's created is half the measure of the intercepted arc. So let's go down here. We know this angle. Now we're trying to figure out the arc. If this is 1/2 of this arc, to find the arc, I need to just double 65. So to double 65, we just multiply by 2. So 65 times 2, which is 130. Okay? And then over here, we would do a very similar thing, okay? So if you want to pause the video and try number 4, you can. All right, so let's go ahead and do this. So we know, same thing, we know this angle is 117, and it's asking to find arc DEF. So to find this whole arc length, okay? So same thing, I'm just going to double this angle. So 117 times 2, 117. Oh gosh. Oops, messed this thing up. Okay. Is 134. So 134 degrees is the measurement of that arc. All right, so now we're going to look, we found the measurements of arcs, now we're going to find the measurements of the angles. So, given the arc. So we know this arc is 260 degrees, okay? And so we're trying to find the measurement of angle 1. So we're kind of just doing the opposite of what we did up here. Instead of multiplying it by 2, we're just going to divide by 2, because we know this angle is 1/2 the intercepted arc. So 260 divided by 2 is 130. Okay? So this next one's a little trickier. Okay, we are not given the intercepted arc here, which is this one with this angle. So, but we can find it, because remember, guys, I told y'all the entire degrees around my circle is 360. So I can find my arc length here by doing 360 minus 140. So when we do that, 360 minus 140, okay, is 220. So 220 is now what I have for that arc length. Okay, so then it just becomes the same type of problem that we did over here. So to find the measurement of this, if we know this whole arc length is 220 degrees, we can just do the measure of angle 3 is 220 divided by 2, or 110. Okay, that's it. All right, this last one, it combines this one, so, and kind of this one a little bit, but we're gonna have to use the same idea, but this time we're involving some variables. So it's a little tricky to wrap your brain around, but if you're just thinking variables are just numbers, okay, just kind of, it'll look a little messy, but as we clean it up, as we keep solving, we'll clean it up a little bit. So we're gonna look at what we did to find this arc. Okay, to find this arc, we took this arc length and we subtracted it from 360. So be very careful, okay? When you're doing this, you do 360 minus, make sure you put this whole thing in parentheses. If you don't, you'll get the wrong answer, okay? So make sure, because that means we have to distribute this negative to both, okay? So that's gonna mess you up if you don't do that. All right, so to find the measurement of this angle, we didn't just subtract this number by 360. We also divided 220 by 2. So let's just go ahead and do that all in one step. Let's just write it all out, okay? So, and we know that's going to equal this angle. All right, so we basically did the same thing we did up here. We just have a bunch of variables, okay? We knew this arc, so we subtracted this arc from 360 to find this arc. Then we know by our definition, right, this arc is, or this angle is 1/2 this arc. So if I divide that arc in half, it'll give me this one. Okay, so we're just setting up an equation. But we gotta distribute a couple things and multiply a couple things. So if I have a fraction here, I wanna multiply both sides by 2. Make sure you put this side in parentheses. You don't just multiply by 2 for this first one, okay? And then we're also gonna distribute this negative. So let's rewrite it. 360 minus 27x minus 14 is equal to 2 times 2x, and then 2 times 18, which would be 4x plus 36. Okay, then from there, you're just solving for x. So I'm going to combine like terms. Okay, 360 minus 14, which is 346. And then I'm going to rewrite it. Okay, and then from there, okay, I just want to move my variables on one side, constants on the other. So I'll cross these out. And here it will get 310 is equal to 31x, okay? And that looks like a pretty great number, right? Because if I divide by 31, I'll just get 10. Can't see this. 10 is equal to x. All right, and so this is going to be a big, big hint. So if you've done all this work and then you realize, oh, goodness, I have a decimal, that means you probably forgot to distribute something. Okay, so go back, look at your work, and see what you did wrong, because I guarantee I'm going to give you guys multiple choice questions for your quiz, and they're not going to have any, what do you call it? They're not going to have any decimals, so don't worry about that. It's not going to be like the trig chapter where we had a bunch of decimals. All right, so let's move on to chord and chord. So my chord definition, you guys remember, said the measure of the angle formed by two chords that intersect inside the circle is 1/2 the sum of the chords' intercepted arcs. So here we're trying to find this angle. This one's pretty easy, right? I know this angle is 145. I know this is 85. So if I add these two and divide by 2, it should give me this angle based on my definition. So I know x would equal 145 plus 85 divided by 2. And you can probably do that in your head if you'd like. I'm gonna put my calculator real quick. 145 plus 85 divided by 2, and that gives me 115. So x is equal to 115. All right, so this next one's a little bit trickier, okay? I'm just gonna kind of walk y'all through the steps, okay? We know, right, that these two added together gives me this length. However, this length right here, we said was, we form a line right here. So it'll be 180 minus whatever this angle is, which right now we know is x, okay? So I would just kind of make those markings, so then now you know how to set it up, since you have a bunch of variables this time. So now I can set it equal to something once I add these and divide by 2. So I'm going to do that. I'm going to do 2x minus 30, just like the last problem, plus 30 divided by 2 is equal to 180 minus x. Okay, because these two angles added together and then divided by 2 should give me this angle that they're intercepted by. Okay, and there's probably more than one way to do this, so if you found another way that works for you, that's fine too. Okay, so I'm not going to hold you to doing it one single way, but this is the way that I find is the easiest. But we'll multiply both sides by 2, multiply by 2, and then these, I'm just going to go ahead and combine those. We know negative 30 plus 30 is just going to go away. So we'll get 2x is equal to 2 times 180, which is 360, 2 times negative x, which is negative 2x. I'm going to add 2x either side. 4x is equal to 360. Okay, divide by 4. X is equal to 90. Okay? So if you have any questions about that, or I went too fast, just pause it, rewind it, and we're also going to have academic labs this week, so that should be helpful for you. Let's go ahead and move on to another question. This one's pretty similar to this one. We know that these two added together will give me this length. So if I do 175 plus 7x minus 8 is equal to, or divided by 2, sorry, is equal to 11x plus 16. So be careful, because I promise you, like, 'cause we're gonna have multiple choice questions, one of the things that is probably gonna be an answer is if you forget to divide by 2. So make sure you don't forget this dividing by 2 part. All right, so we're gonna divide by 2, multiply by 2 on either side. Okay, so we'll get let's do 175 minus 8 first. Let's go ahead and combine like terms. Okay, so that's 167 plus 7x. Make sure you distribute this 2 to both. Okay, the first time I did these problems, I forgot to distribute the 2. Shame on you, Miss Garner, but I did. And so I got a really weird answer. But again, I was like, oh, okay, I got a weird answer. That probably means I did something wrong, so I had to go look back at my work. So just make sure, if you do get something different, go back and look at your work. Okay, so then I'm going to subtract 32 on either side. I'm going to subtract 7x. So these cancel, these cancel. So I'm left with variables over here. 22 minus 7 is 15x. And then 167 minus 32 is equal to 135. Divide by 15. Is equal to 9. Okay. That's it. This last one is super easy, so you're gonna be like, okay, all these other ones are way harder compared to this one, but I still wanna go over something like this because it's gonna be on your quiz. Basically, from going back to our definitions about inscribed angles, you can go ahead and look at that if you like. But an inscribed angle, it's not in the definition, but it was in my examples that it's just double this length. Or sorry, this arc length is just double what this angle is. So I can do one or two things. I could divide this one by 2 and set it equal to that, or I can multiply this whole expression by 2 and set it equal to this one. I mean, it's up to you. I'm probably just gonna multiply this side by 2. So I'll do 2 times 5 plus 4x, just to make sure, again, you distribute. So we get 10 plus 8x okay, so x would equal, I have that over here, 14. There you go. So that's basically it. So that's angles in and on circles. Again, feel free to email me if you have any questions. Miss you guys. See y'all soon. Bye.